Hi. I'm going to run through the material we did in class today, following the outline on the left-hand side, and record it so that you have it to refer to and can pause and play it. And hopefully it'll be a little bit smoother than it was today. So as we described in the slides in class, we're going to build a crude anti-air model where we have a target single string of individual targets coming in randomly, and a shooter that can shoot at them, and a criteria that if they're not destroyed inside a 2-minute time window, that they count as a leaker, and we want to track statistics on how many leakers we have. So to begin this, we have to have an executive block because it is a discrete event simulation, so I'll put that in. Again, I've got my item library open. We're going to create the targets. They're going to go into a queue. From the queue, they're going to go to a server. From the server, they're going to go to an equation, which classifies them as did they get done in 2 minutes or not. Then they're going to go to a select item out block to be sorted based on that attribute value. And from that, they're going to go to exits, where we'll collect them, and they'll exit the simulation. We'll have 2 different exits depending on what their status is. So we'll first build the model, make sure it works, then we'll talk about collecting statistics using a stats block and the other items. Okay, so in the create block, again, good practice is always to label the block, so I'm going to label it create to begin with. Items are going to arrive following an exponential distribution, which is default with a 3-minute time in between, and we're going to set a timing attribute on them when they come in on the options menu, and we're going to call that timing attribute birth time. Okay, one word. Okay, so when each item is created, the birth time will be added to the item as an attribute, which can be read by other blocks. I think that's everything we want to do there. Let's just check quickly. Time units. Doesn't really matter, but it'll just be generic. Okay. So they come out of the create block, and they're going to go into a queue, which we will just label as queue. It'll be first in, first out, which is an assumption, but it's always good to check. And we won't put a capacity constraint on the queue length or have them leave after a certain amount of time if they've waited too long. We'll just have a standard queue. Okay, the activity, which will be our engage block, we'll say initially that there's a maximum of 1 item in the queue, which is the one here, or 1 item in the server at a time. That the delay is going to be specified, at least initially, by distribution. That'll be a normal distribution. We said that we'd have a mean of 1 and a standard deviation of 0.3. I believe that is all that we need to add on this. Yes, so we'll click OK with that. So the items will come into the engage block and go into the equation block. Apparently I missed here. Let's just try a little bit there. Hard to get good help. I'm not going to re-record for this minor thing. Okay, good. So in the equation block, this is a complicated one. So we're going to have a function. The function is going to have an input variable, which is going to be read from an attribute. And the value of that attribute is going to be the birth time. And then we're going to have 2 outputs. So I'm going to put this, I don't really need to, but I'm doing it just because it's easier. I'm going to put 2 rows in there now instead of 1. Okay, and so the first one is also going to be an attribute. The name of that attribute is going to be a new one. We're going to call this one age. And then the second one is also going to be an attribute. And we're going to call this one, we've been using closed, so we'll call it closed. And I recognize perhaps the English of that is not too great. So we need to define what this input-output relationship is, and so we'll have it here as that first age is going to be equal to current time, which is a system variable. I wouldn't expect you would have known that. Oops, I didn't type it right. Current time minus birth time. Okay, and then the second, let's just test that and see what happens when we just hit the test button. Birth time is an undefined variable. Did I misspell it? hasn't been, because I misspelled birth time. Aha. So see, I misspelled birth time earlier, so we'll put that extra N in there just to make life easier. Okay. All right, so that works. And then we'll have a second one which says that if age is less than 2.0, then closed equals 0, semicolon, space, else closed equals 1, semicolon. All right, so let's test all this. We don't get an error message, so life is good. So those are our equations that have been set as I said we would. So type OK. So items will come in here. And now we're going to sort things. We'll either send them to the upper block or to the lower block. And let me go back and just label my equation block equation. Okay, so these are going to be for the items that didn't close. And this is going to be for the items that did close. Okay, so we come in here and then we're going to sort them, and the output's going to be based on a property. The property is going to be based on the value of closed. Okay, and if closed is equal to 0, we're going to output 0. And if closed is equal to 1, we're going to output 1, which when we type it in gives the name of the blocks here, closed and no closed. Okay, and I think this is our sort block. Okay, and I think that completes the basic model. So if I put the animation on this and run through, let's just see how it works. Did I make these planes? Let's make these planes. Just for grins and giggles. Okay, so let's just run through, see how this works. And we should see about 90% of the items go up and 10% go down below. Everything's working, that's always encouraging. And remember, we won't start to see things not close until the queue time is off. They don't come evenly stretched. They come when their queue backs up. That's when we start to have a lot of the failures come in clumps. So we're going to expect to see a couple here. Yeah, there we go. So you're coming in clumps again because they've been spending so much time in the queue until the queue clears. All right, so that seems to work. We'll turn the animation off. And then we end up with 292 and 67. That's because, I didn't adjust the runtime for the model. So instead of being 1,000 hours, it should be 1,000 minutes, it should be 1440. And we'll run it one more time, and then we're getting numbers close to what we expect. Okay, so back over here on my sheet, I have built the anti-error model. We've done the attributes, and we've done the equations. We've noted the importance of spelling your attributes consistently. All right, so if I want to do more than 10 one run, let's say if we're going to do 10 runs here, there's a couple ways to collect the statistics. One of them is to read them off of the actual blocks themselves one at a time, but we're going to use what we call a stats block to collect them for us. So that's in the value menu. All the way down, I get my statistics. I put that anywhere in the model, and then I'm going to tell it to collect statistics on activities. Okay, and I think that's all I need to do, which is fine. So now when I run these 10 runs, the results for the 10 runs are in this model. And again, I can copy and paste either all of it or part of it if I want, but that's one way of getting the data for me. It doesn't give me any information on the inputs, but it gives me information on the outputs. And again, if I want the confidence intervals collected in the machine, in the program extend, I can click on the confidence interval. I can adjust what the value is, amount of confidence I want to have, and it will readjust those proportionally. So we have 13 plus or minus 8 here now. And if I make it 95%, then it is plus or minus 13. So it'll adjust over the data that we're given. Okay, so we can collect the output using the stats block. Another way to do it is to collect the output using a database. To do that, we have to create a database. So we go to Database, New Database. We'll call this DB3 because it's the third one I've done today. We'll put all the data together into one table. New table, call the new table everything. Okay, we'll put in some records in this, fields in it rather. So we'll put a new field in. The first field we'll put in is mean time between arrivals. Okay, the next field we put in is mean time for service. Next field we put in is the standard deviation for service. Next field we put in is max served, which is currently at 1. Then we'll put some output variables in, which is the number closed, and we'll have the number not closed. Okay. Oops. All right, now I've got an extra field in it, which I don't need. So I now have a database that looks like this with no amount of records. Let's put in 100 rows just so we have a placeholder there for later. It's easier to look at. Okay. First thing I want to do is collect the output using the database. Okay, so to do this, I'm going to move it over to the side. Move this, just close this, move that over to the side. To do this, I'm going to use a write block. And I'm going to come up to the here, and I'm going to come up to here. And I'm going to connect the count from the exit blocks from no close and from close into the different write to database blocks. All right, apparently that's good enough. All right, so here I want to send the data to database 3, and it's going to go to the everything table. And the field I'm going to select, since this is a no close, I'm going to go to the one field, and it's going to be the not closed field. And that's good. Now under the options, I'm going to write the data at the end of the run. I don't want to know that it's empty when we start. And then I'm going to make the record index equal to the run number. And I'm going to expand the number of records in the data destination if necessary. So if I run out of the rows I had there, we'll put some more in there. Okay. We'll click OK for that. Actually, I should put write no close. And then similarly for this one, we're going to go to the database 3, to the table everything. The field we'll select will be not closed. Oops, wrong one, closed rather. Okay, and the options we'll have is this will be that we write it at the end of the run as well. The record index is equal to the run number, and we'll expand the number of records if necessary, and click OK. Okay, so now we're going to do these 10 runs that we had set up before. Let's just make sure this works. So we run this now, and now we can see over in our database that those fields have been populated. Okay, so that's pretty good. So we can collect the data using the database output data. Now we want to vary the inputs using the database. So to do that, I'm going to start entering some records into here. We have the mean time between arrival. I'm going to have 5 threes. 1. Sorry. And 5 1.5s. 1.5, 1.5, 1.5, 1.5, 1.5, and so on. So we made the comment that we could put these in an Excel spreadsheet and cover them, probably be easier. So for my mean time for service, here are 10 ones, which let's let me copy, and then come over here and just paste. And that's quite easier to do than what I had been doing. So I think Jennifer, who had the suggestion. Standard deviation was 0.3, so we'll copy that, come over here and paste it. And then the max served is 1. So again, we'll go back to the, oops, missed it. Back here and copy the first 10 rows. And come back to extend and paste that in there too. Okay. So now I've got it set up so that I've got the 4 possible inputs and I can read them from the database. Since from this example I'm only changing 1, I'm only going to do the one read example, and you can do the rest as an exercise. The point's pretty much the same. But to read the value, I need a read block, so I'll come over here. Okay, and I'm going to pull down the menu for my create block, which allows me to say what the mean time between is. So I'm going to read the mean time between arrivals from here. So I'm going to get the data from my database, coming from my everything table. The field I'm going to select is the mean time between arrivals. Okay, I'm going to go to my options. I'm going to read this at the start of the run. I'm going to record number is equal to index number. That should be okay. Click OK. Now I'm just going to connect this here to the mean connector. And now it will read those values, and when I run through it will write to the table both the input values and the output values. So let's go ahead and do that. Okay. And so now when I come to my model, I can see that my close for the first 5 values are in the 40s, and for my last 5 values is in the 400s. So in fact that I have gotten, it's read and it's working correctly. And I could go change the other ones if I want. So now I've satisfied my goal, which is to vary the inputs using the database. So we'll check that off. Now to export data to Minitab, I want to just take this right now. Just going to copy it all. Actually, let me just see if I can copy it all this way. Arg. Not working what I'm trying to do here. I was trying to copy the column headings down too, but apparently I'm not going to be able to do that. So I'm going to copy this, go to my open window of Minitab where I have a fresh sheet. I'm going to put in here right into 1, and I'm going to paste it in. Edit, paste the cells. So the data goes in. This was the MTBA. This was MTS, not that it matters for this point. This was SDS. This was max served. And this was closed. And this was not closed. Okay. So first thing I want to do now is graphically display it. I go to my graph menu. I'll start with a box plot. I want a box plot with simple box plot with groups. So I'll click OK. And the graph variable is going to be, oh, I'm sorry, come back out of that. I wanted to compute the percentage that were not, that closed, or percentage leakers. I'm going to put percent here. I'm going to use the calculator menu to do that. Calculator, I'm going to say, I'm going to store the results in percent. The expression is going to be closed divided by parentheses, oops, not brackets, sorry. Divided by parentheses, closed plus not closed. Okay, so I click OK. And that calculates the percentage for those columns, and that's the thing I'm interested in right now. So again, go to my graph, box plot with groups. I want the percent, and I'm going to separate it on the values of the mean time between arrivals, the 2. Click OK, and here's my box plot, and I can see that there's obviously a graphical a difference between the 2. For a histogram, I would go to my graph, go to histogram menu, same general idea. I want multiple histogram with groups. So again, I'll put in percent here, and the categorical variable will be my mean time between arrivals. and I get a graph similar to the one I had before. And again, I can see there is a clear difference. There's other graphs available there, but we will let them go for right now. Next thing, I want to do my basic statistical estimates and tests. So I'll minimize my graphs. The output of those is going to appear in my session window. I'm going to come from my stats. First thing I want is a confidence interval for percent. I'm going to go down to basic statistics and go to, since it's a small enough sample, I'll go to one sample t, use a t distribution. So the sample is in columns. Under options, we'll set a 95% confidence interval. That's fine. So I'm doing a one sample here. So let me just, what I'm going to get is a one sample t-test confidence interval for the percentage average of all the percent. So we'll go ahead and do that. Let's add some graphics that I can get out of this as well. So I do that and click OK, and here's my box plot for the overall data. Here's my dot plot, which is useful, and here's my histogram, which shows the mixture of two populations. And more importantly, my data is put out here. The numerical results are put here, confidence interval. It shouldn't have been a one sample, it should have been a two sample. So let's do that. Basic statistics, two sample t-test. And the samples are in the one columns percent. The thing that differentiates them is this MTBA again. We're not going to assume equal variances. We'd still like the graphs. Okay, and let's click OK. And now we see the box plots and the difference between the means. And we see, the difference between the means. And here we see the individual dot plots and the differences, nice graphical display. And we have the two sample t-test for the hypothesis that the means are really the same in these two populations. And we see that the p-value is 0 to 4 digits, which means that we reject the hypothesis that the means are the same. Okay, so that's my confidence interval, my two sample t-test. I could do an analysis of variance, which is what I would do for the 3 or more of these. It's in my analysis of variance. My analysis of variance menu. We will do a one-way at this point, simple. Okay, so the response is my percent. My factor is my mean time between arrivals again. Again, 95% confidence interval. And this is basically the same as my two sample t-test. It's just put in a different format when I'm comparing two. And again, here's the plotted confidence intervals for each, showing that they don't overlap. And then the p-value, the F statistic for the test, that the means are the same, and the p-value, which is 0. Again, remember, analysis of variance assumes that the standard deviation is the same for both subpopulations. If I had 3, I would get 3. One other thing about this graphical output, let me just see for this. When I go to my graphs, I can get a box plot which will put this data on it for me as well. And again, now I get the box plot that goes along with the analysis of variance output. So quickly, that's how we do the confidence intervals, the two sample t-tests, and the analysis of variance. And those are the things I wanted to show you in this short time together. I hope this helps you understand what we're trying to do. Again, we're modeling how to test different alternatives, modeling and extend, looking at the different alternatives from an input file, collecting the data, and analyzing it on the backside. So, I hope I'm back in your good graces, and I hope that you all have a good weekend.